Now we're ready to talk about the surface area of pyramids, okay? And let's figure out what a pyramid is. Here's a sample of a pyramid, one of these figures here. Look at the pyramid. Notice that, we're going to talk about all these. The lateral faces of a pyramid are triangles and they intersect at one point or the vertex. Okay, so if all the lateral faces are triangles, that means all these are the lateral faces. They are each a triangle, okay? So each of the lateral faces will be a triangle, okay? And they will intersect at one point at the top, and that is called the vertex, where they all come together at this point is called the vertex. So this is the vertex. Now, the base, there's only one, and it is a polygon. So I've got a bunch of triangles here, and I've got one figure, okay? And that's just its base, all right? In this particular case, the base is, pyramid is named by the shape of its base. Well, what's the shape of this base? Okay, the shape of this base is a square, so this will be known as a square pyramid because the base is square, okay? The base is square. Now, a square pyramid has how many sides to it? Let's talk about lateral edges, where the lateral faces meet or intersect. So this will be a lateral edge, a lateral edge, a lateral edge, a lateral edge, where the lateral faces meet or intersect. Okay? Pyramid will have as many lateral faces as there are sides to the base. So a square pyramid is going to have 4 lateral faces. So what does that say about a triangular pyramid? Its base is named. It's named for its base. So a triangular pyramid has a base that is triangular shaped. So therefore it would have 3 lateral faces. How about a pentagonal or pentagonal pyramid? Pentagonal or pentagonal pyramid, its base has 5 sides, so it would have 5 lateral faces. Octagonal or octagonal would have 8 sides, 8 lateral faces, okay? Pyramid will have as many lateral faces as there are sides on the base polygon, okay? Let's talk about a regular pyramid. Regular pyramid, the vertex of a regular pyramid is perpendicular to the center of the base. Basically what that lets us know is this vertex is directly over the center of the base. If I draw a line straight to the center of the base, it's going to be perpendicular to that base. Now, one more thing we need to know is called slant height. Slant height, or L, is the altitude of one of the lateral faces. Okay? One of the things we're going to have to know is the slant height. Slant height, or called L, is the altitude of, oh, that D doesn't look very good, does it? Let's try that again. D. The altitude of one of the lateral faces. Well, where's the lateral face? Here's the lateral face. Well, what's the altitude of that? Well, it's from the vertex to the center of the base. Right? So the slant height. Notice that from this side, it's slanted. Okay? It's slanted, so we call it the slant height, or it's the altitude of one of the lateral faces. Okay? Now that's the definitions that we have that we need to know. Let's go over again. Lateral faces are triangles and intersect at one point, known as the vertex. The base, there's only one, and it is a polygon. The pyramid is named by the shape of its base. What's the shape of this base? It's a square, so this will be a square pyramid. Lateral edges, where the lateral faces meet or intersect. So this would be a lateral edge, okay? Lateral edge. Regular pyramid, the vertex is perpendicular to the center of the base. So the vertex is directly over the center, and therefore if I draw a line from the vertex to the center of the base, I would have a perpendicular line. That would be the altitude of the pyramid, okay? Altitude of the pyramid would connect the center of the base and the vertex. Excuse me. Also, the pyramid will have as many lateral faces as there are sides on the base of the polygon. So if I have a triangular polygon, how many faces will I have? Triangle has 3 sides, therefore I have 3 faces. If I have a pentagonal, I would have 5 sides, therefore 5 faces. And the slant height, or L, is the altitude of one of the lateral faces. So I take the altitude of one of the triangles, okay? The altitude from the vertex to the center of the base of that altitude of that triangle would be the slant height. Okay, this is the vocabulary we're going to need in order to work with these pyramids and come up with some equations for calculating their surface areas. Okay, some more verbiage we need to talk about on this pyramid stuff is the LSA and the TSA. LSA meaning lateral surface area, just like it did on prisms and on cylinders. So LSA equals PL divided by 2. What's PL divided by 2? Well, P is, same as we're used to, perimeter of the base. Add up the perimeter of the base. The L is the slant height or altitude of one lateral face. Those two are the same thing. The slant height or the altitude of one lateral face. Altitude of one lateral face. The slant height, notice from here to here, it's slanted when you look at it sideways. When you look at it straight on, it would be the altitude of this triangular face. Don't get that confused with the altitude of the pyramid. The altitude of the pyramid is a segment that would connect the vertex with the center of the base. That would be perpendicular to the pyramid. The slant height is not perpendicular to the base of the pyramid. It is perpendicular to the base of the triangle or to its face. Okay? All right. Then our total surface area equals our lateral surface area plus B, or PL divided by 2 plus B. Well, what's B? Area of the base. Okay? And there's only one base, so that's all we're going to do. Okay? Now, what we're going to do is we're going to do some sample problems with this, and we'll be done with this part.